grade 8. The previous section we did was fractions, and so this video is all about revising the section as a whole. So what is everything we need to know from the section on fractions? So I have a couple of questions we're going to work through. The first question is on the topic of comparing and converting fractions. So these are things that we should be good at now because we've been doing them for years. So don't forget that when we compare or convert fractions, basically whatever you do to the denominator of a fraction, so for example here if I'm multiplying 3 by 2 to get 6, then the top of the fraction or the numerator I must also multiply by 2. Why? Because if I'm multiplying by 2 at the top and the bottom, I'm basically multiplying by 2 over 2, which is 1. So I'm actually converting into something that looks different, but because I've multiplied by 1, I haven't changed its value. So if I have a look here, basically I realize that 3 times 2 will be 6, so if I multiply by 2, I'll get 4. And so I know that x would have to be 4. Now you can just go to the side of your page and just think about it. If you were simplifying 4 over 6, you would divide the top by 2, so you'd get 2, and you divide the bottom by 2, so you'd get 3. So basically those are equivalent fractions. And so we keep going. What would you do to 6 to get to 12? I would multiply by 2, so I'm going to multiply by 2 again. And so I get y is equal to 4 times 2, which is 8. If I have a look at the next fraction, I don't know how to go from 12 to 18, so what about from 6 to 18? Or what about from 3 to 18? Well, if I go from 3 to 18, I've multiplied by 6, so 2 times 6 will give me z, and so z is 12. And finally, if I look at, for example, how do I go from 2 to 30, that's multiplied by 15. So basically 3 needs to be multiplied by 15 in order to get w. And so w is equal to 45. So what you do to the bottom, you should do to the top of a fraction if you're converting it to an equivalent fraction. So a fraction with the same value, it just looks different. Okay, so our second question here is about rewriting the following in ascending, which means from smallest to biggest. Don't forget that descending means from biggest to smallest. So from smallest to biggest, ascending. Now you can't compare fractions until they have the same denominator. So if I have a look at 5 as a denominator, 20 and 4, what's the lowest common denominator that I can get them all to? I'm going to write them all over a fraction as 20. So 17 over 20 is already a fraction over 20, but the other two I'm going to convert to a denominator of 20. So if you have a look at the first one, I'm going to multiply 5 by 4 to get me 20, and so 4 times 4 is 16. And finally, I'm going to multiply 4 by 5 to get 20, so 3 times 5 would give me 15 over 20. So I've converted that first and the last fraction to an equivalent fraction, but with a denominator of 20, just because it allows me then to compare. So if it says smallest to biggest, who's the smallest? Well, this one's the smallest, which was 3/4. So therefore, don't forget to go back to the originals. The originals were 3/4. Then the next smallest is actually 16 over 20, which is 4 over 5. And then the biggest is 17 over 20. And so I have written the 3 original fractions in ascending order. So that was the first thing which we should have learned in primary school and which we touched up on. Let's have a look at the next topic. Our next topic is we spoke about adding and subtracting fractions. Now the most important thing with adding and subtracting fractions is you can only do this when you have the same denominator. Really important. You can only do this when the denominators are the same. So you have to you have to convert to a fraction with an LCD. So the first one I'm going to look at is when, example A, when I say 3/4 plus 2/4, where the denominators are the same. So starting off with an easy one, just to remind us, those are the same, so you can do this. Now don't forget that when you add fractions, you only add the tops. So only add the numerators. I'm just going to say the tops because we don't need fancy language here. So 3 plus 2 is 5. But you keep the denominator the same. So this is 5 over 4. Now you can convert that to a mixed number. That would be 1 1/4. In maths in high school, we don't particularly like mixed numbers. So there's nothing wrong with an improper fraction, which is what this one is, as long as it's in simplest form. And 5 divided by 4 doesn't get any simpler. Okay, on to our next one. And so this one, for example, doesn't have the same denominator. My denominator is 4 and 8. So I need an LCD. And my lowest common denominator, 4 and 8, is 8. So I need to convert both of these two denominators of 8. Now the second fraction is already a fraction divided by 8. I'm going to put the negative in because this is negative, so it's got nothing to do with what I need to do. Now I need to multiply 4 by 2 to get 8. So 3 times 2 gives me 6. So I basically land up with negative 6. Don't forget that negative almost belongs to the 6. So I rather think of it like this. It's negative 6 plus 3 divided by 8. So that actually gives me negative 3 over 8, which just check, you always check if your answers can simplify, and that one can't. So don't forget, when you're adding and subtracting fractions, you need an LCD, and then you convert each fraction to that LCD. So let me write a note there for myself. Once I've decided my LCD, I need to convert each fraction to an equivalent fraction with that LCD. So convert each fraction to an equivalent fraction with the LCD, with that lowest common denominator. Basically, after that, I can just add the tops. I should always check if I can simplify at the end. Okay, let's just try 2 more. Next one, 4/5 minus 3/4. Okay, so I first say to myself, right, what's my LCD of 5 and 4? And that comes up a lot, and that's 20. So my second step is then to convert each fraction to a fraction over 20. So I need to convert 4 over 5 to a fraction over 20, and 3 over 4 to a fraction over 20. So what I'm going to do there is, what must 5 multiply by to get to LCD? And whatever you do to the bottom, you do to the top. So I get 16. What must 4 multiply by? That's 5. What you do to the bottom, you do to the top. And finally, I basically just add the tops or subtract the tops. So simplify the top. And 16 take away 15 is 1. So this basically lands up with 1 over 20. Now that definitely can't simplify, but I should always check. Okay, final one, just to revise one extra concept, is this idea of a mixed number. We never, ever in high school work with mixed numbers. So the moment you see a mixed number in any type of fraction question ever, you need to convert the mixed number to an improper fraction. We never, ever work with mixed numbers. So don't be tempted to. So convert the mixed number to an improper fraction. Now don't forget, that's 3 times 2 is 6, plus 1 is 7 over 2. So I get 7 over 2 plus 3/4 minus 1/3. So now I can convert everything to a fraction with an LCD, and the lowest common denominator of 2, 4, and 3, as far as I know, is 12. So I need to convert every fraction to a fraction over 12. So what do you have to multiply 2 to get 12? That's 6. So you multiply the top by 6. So that's 42. Multiply 4 by 3. So that's 9. And multiply 3 by 4. So that's minus 4. So convert to my LCD, and now I can just add my tops. Now you can use your calculator here, but 42 plus 9 is 51, and 51 minus 4 is 47. Now we should always check, can 47 divided by 12 simplify? Now again, of course, that can be converted to a mixed number. We don't like mixed numbers, so I would just see if that can simplify to something easier as an improper fraction. So basically, are there numbers that go into 12 and into 47? Now 4 goes into 12, but it doesn't go into 47. 3 goes into 12, but it doesn't go into 47. 2 goes into 12, but it doesn't go into 47. And so I've checked all the factors. Now there's nothing wrong with just checking that on your calculator. Right, so basically that was adding and subtracting fractions. So just a reminder, you need to create a lowest common denominator, convert each fraction to that lowest common denominator, and then simplify the tops. Just don't forget that we don't like working with mixed numbers. Okay, let's look at multiplying and dividing fractions. We start off with multiplying. There were two methods. The first method is top times top, bottom times bottom, and then simplify. So top times top, bottom times bottom, and then simplify. Now, personally, I don't like this method because often I'm simplifying big numbers that I find very difficult to do. So we are going to look at the second method. So 4 times 15 is 60, and 5 times 2 is 10. Now, actually, that's a fairly easy simplification. The answer is 6. What's the other option? Our other option is to simplify first, then do top times top and bottom times bottom. So literally, the other option is to swap those two around. Now, by that I mean cross-cancelling. So 5 goes into itself once, 5 goes into 15 3 times. Basically, anything at the bottom can simplify with anything at the top. 2 goes into itself once, it goes into 4 twice. So I basically get top times top, which is 2 times 3, which is 6, bottom times bottom, 1 times 1, which is 1. Now, that's not an acceptably simplified answer, because 6 divided by 1 is 6. So those are our two basic methods for multiplication. They're basically just opposite orders. Top times top, bottom times bottom, and then simplify, or simplify first, and then do your top times top, bottom times bottom. Right, let's have a look. Here again, I've thrown in a mixed number. Not a problem. I deliberately made it negative, so we can practice the fact that this just means it's negative. It doesn't have any bearing on the mixed number. So 2 times 3 is 6, plus 1 is 7. So it's 7 divided by 3. Now I'm going to put that in a bracket because I'm just too lazy to write multiplication signs. So there we go. Now, again, you could do top times top and bottom times bottom. So don't forget that a negative times a negative is a positive, so that doesn't matter. 7 times 6 is 42. And 3 times 21 at the bottom is 3 times 20 is 60. 1 times 3 is 3. Now again, you might be sitting here going, oh, does that divide? How do I simplify? And it's quite annoying, which is why I prefer to do the cross-cancelling first. You can just put that in your calculator and check, but basically both sides are both numerator and denominator divisible by 21, so I get 2 over 3. Personally, I would have preferred to leave it as negative 7 over 3 multiplied by negative 6 over 21. The negative times the negative cancel, so in my next line I can immediately know it's positive. I'm just putting that there. 3 goes into itself once, goes into 6 twice. 7 goes into itself once, goes into 21 3 times. So basically get 1 times 1 at the top, which is 2, 1 times 2, which is 2, and 1 times 3, which is 3. And I go straight to my answer. Okay, now that we've done multiplication, let's do division. Now division is really easy because we don't like to divide. So we change the divide to a multiplication sign and we multiply by the flipped over version of that fraction. So basically it's called tippings and timesing. So you tip the fraction that you're dividing by and you times it. Notice this first fraction, you weren't dividing by that fraction, so it remains unchanged. So basically you tip the fraction you're dividing by. So tip the fraction you are dividing by, and then you times. And your division sign changes to times. So when I was at school, we always remembered tip and times was our kind of memory aid. Okay, now you're back to multiplying. And again, you could do top times top, bottom times bottom. I'm going to rather settle now into multiplying by using cross-cancelling. So 4 goes into itself once. 4 goes into 16 4 times. 3 goes into itself once. Try and do this neatly so the person can see that you did tip in times. You mustn't scratch things out so we can't see that. 3 goes into 9 twice. So I land up with 4 over 2 because 1 times 4 is 4, 1 times 2 is 2. Now, if I just think for a second, 4 divided by 2 can actually simplify further. So I got 2. Now I could have actually done that simplifying, because I could have done more cross-cancelling. I could have said 2 goes into itself once, goes into 4 twice. So I basically get 2 over 1, which is 2. So you can keep going with your cross-cancelling multiple times. Okay, last division one. Let's have a look. Tip and time. So 14 stays the same, and I'm going to multiply by what we call the reciprocal, so the flipped over version. If you do cross-cancelling, which I would prefer always, 7 goes into itself once, goes into 14 twice. So I get 2 times 3, which is 6. And lots of people don't know what to do at the bottom here. Don't forget that every whole number has an invisible denominator of 1. So my denominators are 1 times 1, which is 1. So this is actually 6. Right, so now we've revised multiplication and division of fractions. So the second last thing that we need to do is to look at what happens if we mix the operations together. Now the most important thing that I've said ever is divide into terms. Don't even worry about BODMAS or horrible things of what do I do first and start freaking out. Divide into terms. Don't forget that the terms are divided or separated by plus signs and minus signs. So the moment I see a plus, I put a line there. That is a separate term. This is one term because it's glued together by multiplication. So my first step here would be to change my 2 1/3 to a improper fraction. We don't like mixed numbers. So multiply. 2 times 3 is 6, plus 1 is 7. So it's 7 over 3. Plus, now I need to simplify my fractions. Now that's a multiplication, so I'm going to do my cross-cancelling. So 2 goes into itself once, goes into 4 twice. 3 goes into itself once, goes into 9 3 times. So I get 1 times 2 at the top, which is 2. 1 times 2 at the bottom, which is 3. Okay, just triple checking that that's right. Of course, you could have done top times top, bottom times bottom. So you could have said 7 over 3, and then you would have had 3 times 4 is 12, and 2 times 9, which is 18. You would then have to go, what I don't like about this method is now you feel like you need to convert these to an LCD, so you start moving everything to 18ths, whereas actually if I have a look here, hang on, these two have the same denominator if I simplify. Now some people forget to do that, so now they start doing complicated things of getting everything to an LCD of 18, whereas you can actually just simplify. So if you do top times top, bottom times bottom, try to always simplify your fraction first before you start adding, simply because it could make your life much easier. Now when I add, don't forget I add the tops, and my denominators are the same, and guess what? 9 over 3 is actually 3. Okay, let's do another example to practice this order of work. Right, 2 divided by, and hang on, this is a bracket. So how many terms here? This is one ginormous term. Yes, there's a subtraction sign there, but it is inside a bracket, so that bracket kind of overrides everything. So this is 2 divided by, and I can't tip and times or anything because that bracket is not one term yet. So I first have to sort out that bracket. So you can't do parts of the sum and not other parts. So I keep everything in the sum except I work on the part that I'm currently interested in. So notice the 2 is still there, the divide is still there. I need to change everything in the bracket to a denominator of 12 because that would be an LCD. So what do? I need to multiply 3 times 4. So I multiply the top by 4, so I get 4. I need to multiply 4 times 3, so 1 times 3, which is 3. So notice the rest of the question stays as is. So I've still got the 2, I've still got the divide, and 4 minus 3 is 1, so it's 1/12. Now this is an easy question because I can tip and times. So I'm going to multiply and swap over my fraction. So now I can multiply top times top, bottom times bottom. Technically 2 is 2 over 1, so I get 2 times 12, which is 24, over 1 times 1, which is 1, and 24 divided by 1 I should and must simplify to just plain 24. Okay, last one under this order of work stuff. divide into terms. There are two separate terms here, and so first I need to work out each term. Now, I personally would work on both terms in the same line. So by that I mean I would say, okay, equals. Now I'm just going to rewrite this so it's 6 over 5, just so I can see a bit more easily, minus, and it's a half divided by 5 over 4. So I'm actually just going to put in a bracket there and a bracket there, not because I need it, but because it just helps me see what I'm working with. Now, can you do any cross cancelling? I can. 3 goes into itself once, goes into 6 twice. So my first term becomes 1 times 2 at the top, which is 2, and 1 times 5, which is 5. Now, minus, my second term is a division, so I'm going to tip in times. So I'm going to change this to a half, multiply and tip it over 4 times 5. Now notice the rest of the question has to come along for the ride. So you've still got this 2/5. You can't drop it and do parts of the question. So this is now subtract, and I'm going to do some cross cancelling. 2 goes into itself once, goes into 4 twice. And so now I get top times top, bottom times bottom. So I get 1 times 2, which is 2, 1 times 5, which is 5. And oh my word, I have 2/5 minus 2/5, which technically is 0 over 5. But what's 0 divided by anything except 0? But 0 divided by any non-zero number is just 0. I could have jumped straight from there to there, because I should have said to myself, well, if you have a number and you take it away, it's gone. So I'm left with nothing. Now that's the end of mixed operations. So the last thing we have to look at is we're just looking at a couple of word sums. So some of these word sums we're going to use the bar models to help us with, and some of them we can do without bar models. So my first kind of process is always just to think, can I just work it out by thinking? So the first question says you have 7/8 of a litre, I should say of a litre of cold drink. You pour this into 14 cups. So you have a little jug here, which I'm really not going to be able to draw very well, so pardon my drawing. Yep. And inside of this you have 7/8 of a litre, and I need to pour this into 14 cups. What fraction of a litre will be in each cup? So I'm basically dividing this into 14 cups. So this doesn't need a bar model or anything. There's 7/8 of the litre, and I'm dividing it into 14 cups. So if I'm not allowed a calculator, I need to realize that this is technically 14 over 1. So I'm going to tip in times, so it's 1 over 14. So if I'm simplifying this, 7 goes into itself once, goes into 14 twice. And now I can do top times top, which is 1 times 1, and bottom times bottom. So 1/16 of a litre, because it said what fraction of a litre. So 1/16 of a litre will be in each cup. So no bar models needed. So always think first. Next question. Sarah has 64 pairs of shoes. That's more than enough. She donates 1/8 of these to charity. Now, can I work that out? Is that a simple process, or do I need a bar model? Well, let's think about it. What is 1/8 of 64? Well, 1/8 of 64, I know 8 times 8 is 64, so 1/8 is 8 pairs of shoes. Now, I could probably cheat and do it on my calculator, but that was a fairly easy calculation, because basically 8 goes into itself once and into 64 8 times, so 1 times 8. Okay, so she basically donates, so now I know that she donates 8 pairs of shoes. 3/7 of these she gave away to her friends. So 3/7, now it didn't say 3/7 of what she had left, it says 3/7 of these she gave away to a friend. Now this is where I've made a typo, so let me just change this for a second. Now how do I know I made a typo? Well, I can't work out 3/7 of 64 when you get a whole number, so I clearly made a typo. I meant to say she donates 1/8 of these to charities, and 3/7 of the remainder. 3/7 of the remaining shoes. So let me just change this. My apologies. Let me change this and read it to you again. So Sarah has 64 pairs of shoes. She donates 1/8 of these to charity. Full stop. 3/7 of the remaining shoes she gave away to a friend. Now that means I need to know how many shoes are remaining. So I know she started with 64 pairs of shoes, and she's taken away 8 because she's donated them. So she lands up with 56 pairs of shoes. Now 3/7 of these she gives away to a friend. So 3/7 of the 56 she gives away to a friend. Now I can, if they say I can use a calculator. If they don't say I can't use a calculator, I'll choose my calculator. But this is fairly simple because 7 goes into itself once, but goes into 56 8 times. So I basically get 3 times 8. The denominator is 1, but 24 divided by 1 doesn't matter. So 24 pairs she gives away to a friend. How many pairs does she still have? So she had 64 pairs. She donated 8. And then she gave 24 pairs away to a friend. So if I take 64, subtract 8, subtract 24, I get that she has 32 pairs of shoes left over. So basically, she has half of them. Now again, I didn't need a bar model here, because if I just read through it and slowly but surely, kind of worked my way with the fractions, it completely was doable. So don't jump to a bar model unless you need it. Apologies for my typo there. I hope it makes sense. Okay, our last question. Tessa gets paid a salary each month. Cool. She gives 1/5 to the SPCA. Now, can we see the difference between B and C? In B, I said to you, Sarah has 64 pairs of shoes. So I told you how many she had. So when I say that she donates 1/8, I can actually work out what she donates. This question says Tessa gets paid a salary. I don't know what salary she gets paid. So when it says she gives 1/5 to the SPCA, I can't actually work out what she gives to the SPCA because I don't know. So this is why I'm kind of thinking a bar model might help. So let's start. I draw a whole long bar to represent her salary. Now 1/5 she gives to the SPCA, so I'm going to divide into 5. 1, 2, 3, 4, 5. So 1/5 of these she gives to the SPCA. A half of it she gives to her mom. Okay, so a half of her entire salary she gives to her mom. Now the problem is I can't do a half of this because there's 5 bars here, and if I want to donate half of 5 bars, that's 2.5 bars, and that's not working for me. So basically I'm going to divide every single bar in half so that I can actually represent a half of these bars. Now you'll notice that when I divide each bar in half, I'm going to land up with 10 bars, and guess what? 10 is the lowest common denominator of 5 and 2. So if I divide this into a half, and 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 this into a half, it basically means I have a total of 10 bars. Now, so if she donated half, that doesn't say bars, so let me erase. If she donated half of these bars, she would have donated 5. So therefore, half would equal, now that doesn't say half, my apologies, so half would equal 5 bars. So 1, 2, 3, 4, 5, this is her mom. So if we're looking at the whole now being 10 bars, 2 of those bars goes to the SPCA. So notice that means 2 bars out of 10, which guess what? That's 1/5. Her mom gets 5 bars out of 10, and guess what? That's a half. So this makes sense. The rest she keeps to live off. So basically 3 blocks. I should be calling them blocks. 3 blocks. Sorry, I should be calling them blocks and not bars, because that's what we normally do. We call the whole thing a bar and we call these blocks. So let me cross those out. 3 blocks is what she lives off. Now it says if she lives off 2,000 Rand more than she gives to the SPCA. So basically 2 blocks is the SPCA, and she lives off 3 blocks. This is what she lives off. Now this question says she lives off 2,000 Rand more. So therefore 3 blocks is 2,000 Rand more than 2 blocks. So if I compare these, she lives off 1 block more. Now, if she lived off multiple blocks more, then their multiple blocks would represent 2,000, and then we'd have to work out what one block represents. But here we're lucky. She lives off 1 more block, and she lives off 2,000 Rand. So therefore, 1 block, she lives off 2,000 Rand more, 1 block is going to equal 2,000 Rand. So I know that this little block here is 2,000 Rand, and every single block is 2,000 Rand. So what is her salary? Well, in this particular question, we had 10 blocks, each worth 2,000 Rand, and so she earns 20,000 Rand. So in this bar model idea, the idea is always to figure out what is 1 block worth. Because when you figure out what 1 block is worth, you can do anything. Now, I knew this happened to be a bar model question because they didn't give me an original amount of money to start with. And so I was forced into a bar model. So I think the most difficult thing with the word sums is, do I use a bar model? I don't. Well, there's nothing wrong with starting the question and seeing if it works, and if it doesn't work, then try a bar. I'm hoping that this is a fairly comprehensive revision of all the fraction work that we have done so far. So I'm hoping that this kind of rounds up the section and gives you some good revision.